Hello everyone. Let's do an extra video lecture because for the review class we don't have time to talk about the worksheets for this test. So let's do this extra video lecture to talk about the worksheets. So let's start with this worksheets 3. And for the first question, we have this sample sleep data set. So these are the values we have in the data set. And we are required to calculate the mean, median, mode, and range. And we also want to describe the shape. So let's look at the mean. So for calculating the mean, so we say is the sample mean, x bar. So it is sum of x over n. So we're going to look at how many numbers we have in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So our n equals 20. That tells us we have 20 numbers in this data set. And then we want to look at the sum of all the values and then divide it by 20. So now let's use this calculator, just type in everything. So we have 4.5, 4.5, 5.0, 5.3, 5.7, 7, 6, 6, 6, 5, 6.5, 6.7, 7, then 7.3, and then the last one is 10. So we type in everything. So let's see the least. And then let's check whether we have 20 numbers there. Yes, we do. So I think we're good on typing the data in. So then we're gonna look at the total, add up everything together. So that's 133.2, and then divided by 20. So we have 6.66 as the mean of this data. And then we're going to look at the median. So the median is, since we have even count for data set, then the median will be two values right in the middle. So we actually want to find the 10th and then 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these two values are located right in the middle. So median will be the average of these two numbers. So 6.5 plus 6.7 divided by 2. And then let's see, 6.5 plus 6.7, 13.2 divided by 2, that's 6.6. So that's the median. And then what's the mode? So mode will be so 3 times for 6.0, 3 times for 6.7, and 3 times for 7.3. So we have multimodal here. So we have 3 modes. Okay, that's a mode. And then we want to look at our range, which is the maximum minus the minimum. Since this data is already properly ordered, so we're good. Just look at the largest, which is 10, and then minus 4.5. So we got 5.5 as our range. And then we want to describe the shape. So basically we want to compare the mean and then the median. So since our mean is larger than the median, so that tells us what? So median is right in the middle. That's median. And then our mean is larger than the median. Okay, so we need to draw a symmetric distribution first. And then since mean and median both describe the center, so originally they should all locate right in the middle. And now our mean is more than the median. So that means our mean is shift to the right a little bit. That makes the mean is more than the median. And the reason that the mean is more than the median is because we have some unusual large number that makes the mean getting larger or pull to the right tail direction. Then we say we have some unusual large. So we're gonna add a long right tail here that describing the shape. So then we say when mean is more than the median, when we have right skewed. Right skewed. That's the shape. And then range rule of thumb to get the standard deviation. So using the rule is range divided by 4. So we have 5.5 divided by 4. So then, let's see, 1.375. That's the estimated standard deviation. And we want to report the 5-number summary and then the 73rd percentile. 5-number summary. So we have Q2, which is the median, the 50th percentile. So we have that already, which is 6.6. And let's find Q1. So for Q1, that is P25. So we want to look at the position. That's 25% times n. So which is 0.25 times 20. So 0.25 times 20 give us 5, which is an integer. So we're looking at the 5th and the next one, the 6th ordered number. So let's see, 1, 2, 3, 4, 5. So the 5th and the 6th ordered value is 5.7 and 6.0. So that tells us Q1 equals divided by 2. So that is 5.7 plus 6 divided by 2, 5.85. And then for Q3, that's P75, 75th percentile. So that's 75% times n to get the location. So 0.75 times 20. So that's 15. Integer again, so we have to look at the next one, the 15th and the 16th. So that lead Q3 equals what? So 20, 19, 18, 17, 16, and 15. So they're both the 15th ordered value and the 16th ordered value. They're both 7.3. So Q3 equals 7.3 plus 7.3 divided by 2, which is still 7.3. So that's Q3. So then we can report our 5-number summary. So we are gonna make a table and state what are the 5-number summary. Minimum Q1, Q2, Q3, and then the maximum 5-number summary. The minimum is 4.5. The maximum is 10. And Q1, 5.85. Q2, 6.6. And Q3, 7.3. So that is the 5-number summary. And we need to note that the values here in this table, they're going to be non-decreasing. So if you see Q2 is even larger than your Q3, then you have some problem because they're representing percentile or quartiles. So they should be non-decreasing. And for this P73, the 73rd percentile, then we're going to look at 73% times 20 to look at the position. So 0.73 times 20, that gives us 14.6. So then we want to round up to look at the 15th order value, and which is 7.3. So that tells us the P73 is also 7.3. 7.3. So that's this question. And then we can calculate the IQR for the next question. So interquartile range is Q3 minus Q1. So that's 7.3 minus 5.85. That gives us 1.45. And then 1.5 IQR equals 1.5 times 1.45. Which is 2.175. So this is the 1.5 IQR rule, the distance that we're using to make our lower fence, and then our upper fence. The lower fence is starting from Q1, even getting lower, so minus 1.5 IQR. And the upper fence is starting from the 3rd quartile to get higher. So that's plus 1.5 IQR. So Q1, 5.85 minus 2.175, that gives us a lower fence. And Q3, 7.3 plus 2.175, that gives us the upper fence. So 5.85 minus 2.175. So that is 3.675. And then 7.3 plus 2.175. So that gives us 9.475. So that is a range. The lower and upper fence give us a range. So that is from 3.675 to 9.475. So anything outside the range we consider as the outlier. So from the lower end, the lowest number is 4.5. It's still within, so no problem. Let's look at the higher end of the data set. So 10 is the maximum. It is an outlier because 10 is outside. So we say 10 is an outlier. But other than that, we're all good because the next largest will be 8.5. That's within. And then we're going to draw a box plot. So we're going to draw the one with this outlier also show there. So we're just going to draw a line representing the numerical scale, and then just put some reasonable number there. And so we're going to start with something even smaller than our minimum, and then up to something even larger than our maximum. So 4, 5, 6, 7, 8, 9, 10, and 11. Just make your drawing reasonable. You don't want to have something that is too wild, like since 8 minus 7 is same as 10 minus 9, so the distance should be the same. And we're gonna start with Q1. So Q1 is 5.85. So somewhere here. So that's our Q1. And Q2 is 6.6. So right here. And Q3 7.3. So right here. And then we connect those little longer line to a box. We'll label Q1, Q2, Q3. And then we have the two adjacent values. The smallest within the fence, which is 4.5. So a shorter line, and then connect to the box. And then the upper adjacent value, which is the largest number but within the fence. So that's the second largest number, 8.5. So we have 8.5 here, and then connect to the main box. And then we label the outlier, which is our 10. So that's a box plot. So if we look at the shape, without the outlier, is pretty symmetric. So if we put a smooth curve, and then it should be something like this without this outlier. And we also want to find question 6. We want to find the standard deviation and variance for the data set for this one. So using the definition formula. So definition formula is sum of x minus x bar squared over n minus 1. So we need to know x bar first. X bar is the mean. So 6.0 plus 6.7 plus 7.3 over 3. So let's see what it is. 6 plus 6.7 plus 7.3. 20 divided by 3. So 6.67. That's x bar. So every single value in your data set minus the mean, and then you squared it plus the next one. 6.57 minus 6.67 squared plus 7.3 minus 6.67 and then squared over 3. That's an n, right? We have 3 numbers. So then we're gonna look at what it is. Let's type in 6 minus 6.67 squared plus 6.7 minus squared and plus 7.3 minus 6.67 and then squared. So that is 0.8467 divided by 2. So that's 0.4234. That's by the definition formula. Then we're going to look at the other data set using we're going to use the shortcut formula. We forgot to do the standard deviation, so let's do it. Standard deviation is just square root of the variance, 0.4234. That's what 0.4234. Take the square root, so we got 0.6507. And for data set 2, the shortcut formula is sum of x squared minus sum of x squared over n, and after the difference we divide it by n minus 1. So then we need sum of x and sum of x squared. So let's see, we're just going to list a table. X will be 5, 8, and 10. So sum of x is 23. So add these 3 numbers together. So squared. So 5 squared, 8 squared, and 10 squared. Then we have 189, that is sum of x squared. Then plug in. So 189 minus 23 squared over 3 and over 2. So let's see what it is. If you want to type the entire from equation into your calculator, then you have to include this parenthesis. So that'll let the calculator know you want to calculate the difference first, and then take divide it by 2. So that's going to be 6.33. That's for using the shortcut formula, and we also need the standard deviation. So square root will be 2.516. And then compare using the C bar. So C bar 1 will be the first one. So standard deviation of the first data set divided by the mean of the first one. So let's say this is x1 bar, and then s1 squared, s1. So s1 is 0.6507 divided by x1 bar, 6.67. So let's see what it is. 0.6507 divided by 6.67. So that's 9.76%. C-var 2. So we do have S2 standard deviation, but we don't have x2 bar. So x2 bar will be sum of x2, 23 over 3. And S2 is 2.516. Let's see what it is. 2.516 divided by 23 divided by 3. Don't forget the parentheses. And then we got 32.82%. So coefficient of variation of the second data set is way larger than the first one. So that tells us data set 1 is more stable. And then question number 9. Adult IQ scores have a bell-shaped distribution. So that is an important information with the mean and standard deviation. So what percentage of adults have IQ score between 80 and 140? So from the bell-shaped distribution, then we know we want to use empirical rule. Then we have a bell-shaped partition of the areas, or because the areas represent the probability, that's partition of the probability. Then we can know what percentage of adults have IQ score between certain numbers. Then let's see, the mean right in the middle, 120. And then we want to look at one standard deviation away. Since the standard deviation is 20, so one standard deviation away, that gave us 100 to 140. So minus 20 plus 20, right? And then 2 standard deviation, go one more. So the standard deviation is 20, so that gives us 80 and 160. So one more, that's 180, and that's 60. And then we want to know the area between 80 to 140. So that is this shaded area. And actually, we know the partition already, right? So we did that in class. So one standard deviation away from the mean. So that area is 68%. Symmetry, that give us 34%. And then these two area, they're the same, and each one left 13.5. So actually, what percentage of adults have IQ score between 80 and 140? That is 13.5 plus 34 plus 34. So that is 81.5%. Okay, let's look at the last question. The z-score for 6 of dataset 1. X1 bar is what? The standard deviation. X1 bar, let's kind of recall the calculation right here. 6.67. And standard deviation 0.6507. So relative standing, so 6 compared to the mean, that is how many standard deviations away. So we say z of this 6.0 is x minus x bar over standard deviation, and that is 6.0 minus x bar, 6.67, and divided by the standard deviation. So negative 0.67 divided by 0.6507. So negative 1.03. So this means what? 6.0 is actually left of the mean with about 1 standard deviation away from the mean. And that's why we call the z-score is expressing the relative standing. Okay, that's all for worksheet 3, and I'll make 2 other videos for worksheet 4 and 5. Thanks.